Right, so I want to do one more animation, and it all involves graphing a circle and using a little trig to plot some points. So it's good if you want to do any kind of circular motion. Trigonometry is useful for that because it can help us find the points around a circle. So first off, I'll show you what we want to draw is the big wheel in Seattle. And I want to kind of use colors, blue and green, to rotate around. So I'm not going to have my spokes different colors within each spoke, but I'm going to have the spokes alternate colors, so it looks like the wheel is spinning. So there's the picture. It's downtown if you want to go see it. So I'll draw that here to start, and we can start talking about what that's going to look like. So first off, I'll get a pretty big circle here. Come on, there's my circle. And what I want to do is draw spokes in this circle. So this circle will be in a window. Maybe I'll make my circle a little smaller. Make this a little bigger. Let's move it over a bit. So I'm going to put that in a window. So draw a window around it. And that's going to be the first thing that we need to do, is just figure out how to draw this circle. We know how to draw an oval, so it's just figuring out what is the corner that we're talking about here. And then I'm going to draw spokes that come out from the center. And let's cut this circle into 4 pieces first. Sorry, I should use the automatic line button. And then I want to cut each of these into thirds. So these will be coming out, if you've studied trigonometry, each at, maybe some of you are in the trig right now, each at an angle of 30 degrees, or pi over 6 is what we'll use. So, you know, the total as you go around is 12 pi over 6. So that first angle is pi over 6. And if you go all the way around, it's going to be 12 pi over 6. So this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. So as we try to figure out, as we go around this loop, 1 to 12, because there are 12 spokes, and then each one is going to somehow be related to pi over 6. And you know, if you remember from trig, each point on here will have coordinates cosine of theta, sine of theta, and maybe times the radius r. So I'll put an r in front of there, an r in front of there, where theta is the angle up from the horizontal. Okay. So go back to our Java for a second. We need to put this circle inside of a square that has a corner up here. So we'll make that corner, say, at, let's make our window, let's see, 300, 450, 600, maybe 600 by 600. So we'll go 600 across, 600 down. And then let's have this be 150 over. I'm not sure if it's going to work. 150 down. And then this box, maybe I'll make a lighter green here so it doesn't interfere with. Our circle will have a diameter of 300, or a radius of 150. So this distance here will be 300. That distance there will be 300. And then that'd be 300, 450, and then there'll be another 150 over here on each side. So it's fitting in the middle of the window, and it's in the middle of the square. Okay, so I'm going to need first to draw that circle, and then I'm going to need to figure out the center point of this circle. And the center point here is going to be at where? Let's right over here, center. Well, you got to go 150 and then 150 more, so that's 300. And same thing in the y direction, down 150 and down 150 more. So 300, 300 is the center. Okay, so I'm going to just draw the circle and go from there. We'll come back to paper in a second. This is a cool graphics demo that's posted in, I think it's in week 4 in Canvas. It just shows a ball rolling across and then dripping and dropping down and rolling down. So you could download that and put it in your Eclipse Java project folder for chapter 3G. And it's not related to the project I'm working on now, but I just had it open. So I just thought I'd show it to you. It's actually not that long of a code. It's using an if state, a couple of if statements having to do with when should it drop and when should it roll right using a direction, or when should it roll left. So you can look at that code and maybe that can help you with some of your animation stuff for project 2A. It's not that long, as you can see. A couple of methods. In any case, it's posted on Canvas, so you can look at it there. We are going to do our own. And you know, it goes beyond anything we've done so far, but you could probably trace through the code and figure out what's going on in there. Call it big wheel. That other code I just showed. Again, it's posted on Canvas in week 4. Your science 142, today's date, and then this class will draw a big wheel with spokes that rotate as if the wheel were spinning. And so notice that if I forget to do the import, well, let's import it. I like to do it. Import Java. It'll do it. Eclipse will do it for us if we forget. AWT.star. And we need to start with a new drawing panel. Let's use the word panel. Equals new drawing panel. And I think I said 600 by 600. And then we need a new graphics object to be able to draw in that panel. So I'll call it graphics graph equals, it's a method of the panel, so it's panel.getGraphics. It'll return a new graphics object for us. And then it'll know to draw on that panel. Okay. And then we want to put a circle of radius 150, making sure my window opens. So this is an interesting thing. Notice my window is not square. And that's because my monitor is not square. So 600 pixels in one direction does not look quite the same as 600 pixels in another. So you might notice that on yours. Hopefully our circle will still look like a circle. This can cause circles to look different if your aspect, it's called your aspect ratio. If it's too far off, it makes circles look like ovals. Okay, so we're gonna graph dot draw circle or draw oval. And it has an XY initial left corner 150, 150. And it has a height and width also of 150, 150. Is that true? Yes. And then we'll run it and see if we get it. And I'm just trying to figure out why that's not in the middle of my page. And also it feels a little small to me. So go back to my picture for a second. Clearly this is not to scale. 300, 450, 500, 600, and then this way is 150, 150, 150, it's 300. So 300 by 300. So this point down here would be 450, 450. Then leave 150 and 150. So why does it look so different on my screen? It looks much wider than I want it to. Oh, I know why. These aren't 150s, these are 300s. Sorry, it's the total distance across, not the radius. Which I have in the picture, I just wasn't looking at my picture when I drew it. There we go. Okay, so that's what I want, my big wheel. And then I want to draw the spokes, and I want them to start at the center and go out to the edge. So I wonder if it'll let me draw on here. No, it'd be cool if I could. Okay, so back over here, the center is at 300, 300. And then, so we're gonna draw a line from 300, 300 out to here. And this point, there's gonna be 12 of them. 3, 4, 5, no, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm just gonna scroll down for a minute. Each one of those points, each one of those line segments goes from 300, 300 in the middle, to the X value on the outside and the Y value on the outside. But those are each determined by the radius R times the cosine of the angle in radians, the radius of the circle R times the sine of the angle in radians. So if we're, say, for I equal 1 to 12, then the radius is 150. The angle is I times pi over 12. And as you go from, I'm sorry, pi over 6. And as you go from 1 to 12, you're going to get 1 pi over 6, 2 pi over 6, 3 pi over 6, up to 12 pi over 6, which is 2 pi. Okay, the problem with this logic is that these are irrational numbers. Pi over 6 is an irrational number, and sine and cosine are going to produce irrational numbers there. Well, not always, but they toggle between root 3 over 2 and 1/2. So the root 3 over 2 is irrational. 1/2 would be fine, except not really, because, well, if we multiply by 150, it would be fine, be 75. But ultimately, we need them to be integers because they represent pixels, and we can't get in between 2 pixels. So we're going to have to integer cast both of these things. So I don't think we've done yet. Okay. So we'll go back, write our loop, and draw 12 lines. For integer I equals 1, I less than or equal to 12, increase I by 1. Let's set an X value and a Y value. So we'll go integer X equals, it's going to be the integer cast of the R which is 150 times the cosine of theta. So to get the cosine, we have to go math dot cosine of, now it's going to be I, and then times, we need pi, so that's math dot pi, capital Pi, and then divided, maybe open and closed. Nope, I don't think it, math dot pi divided by 6. And I'm gonna guess that we might need to put this all in parentheses. I'm just gonna try it and then put a semicolon after it. Okay. So that worked. I'll give you a second to absorb that, and then I'm gonna just copy and paste it in for y. You know, when you have these really complicated, I mean, this is not that complicated of a formula, but it's involved. I'm going to type that in for y and just change the cosine to the sine. I could put those within the draw line code, but you know, these are complicated enough. So maybe I just say out here, you know, find the x and y are points on the circle. At each multiple of pi over 6. So we put a comment in there so that you can understand why we're doing that. And then we're ready to draw. So we'll go graph dot draw line. And we're going to start all our lines in the center of the circle, 300, 300. And we'll go to x to y. So, you know, I don't need x and y. I could put in this draw line function call all that math, but it's clearer, it's easier to see the math separate and then draw the line. And this loop should give me my wheel. I'm going to clean up some of my white space while you get, you know, caught up here. It just tightens the code up so that you have less sort of space around to make errors in. I'll hit draw. Whoa, it's cool, but it's not what we wanted. And I'm staring at it going, wow, it is cool looking. Oh, I know why. Yeah. So what I didn't do is I didn't translate my circle. These values for x and y are a circle that's centered at the origin, but our circle is centered at 300, 300. So we actually have to add 300 to both these values, because it's a translation of the circle. So the x and the y, this gets you to the edge of the circle, but you had to start in the center. Yay. But that first one is cool looking too, right? Because it's drawing out to somewhere. I don't know, like, why are some of them longer? It's cool. Anyways, so some things can happen and sometimes they can look really neat. All right, so there's our big wheel. And then the way that I want to make it move is I want to actually change the colors of the spokes. So I want them to sort of look like they're spinning by first sort of turning every other spoke green and then every other spoke blue. And I want it to look like, I'll actually show you what I want it to look like. I have one somewhere. Let's see if it's in here. Well, maybe I'll just wait because I'd rather have you see it when we finish it. Sorry, technical difficulties. Okay, so what I want to do is we want to do this drawing of the spokes in a loop, and we want that loop to run, I don't know, a bunch of times. So, you know, let's say it's going to run, let's start off by running 40 times. So for integer j equals Doesn't matter. Let's go 1, j less than or equal to 40, j plus plus, and then I want to put all that code inside the loop. So I'm going to make the loop and then copy this loop out, cut it out, and paste inside of there. And then, you know, what's going to happen here is I want the colors of the spokes to alternate. And so, you know, J is going to start off, I think, at 1, and I is going to run 1 through 12. And so let's suppose you want your first spoke to be green. Then the next one should be blue. And then the next one should be green. And the next one should be blue. And you could just have them alternate based on I alone, but then every spoke would stay the same color. So it would go green, blue, green, blue, green, blue all the way around, which we could do. And then, so let me show you that in the code first. So we could say in here, before we draw the line, if, so I'm going to do our if statement. This is leading us into chapter 4. If I divided by 2, if I divides evenly by 2, so if I mod 2 is 0, open our if statement. We'll do graph dot set color to color dot green. And then we'll say so run this. It's going to make every other one green. But it doesn't look like it makes them all green, actually. Oh, by the way, when I do the comparison, I need double equal sign. If I mod 2 is 0, oh, it sets it to green and then it stays green. So every time we draw it again, it never changes back. So it's 0, it turns green in the very beginning and then it never changes back to black. So that's fine. And then we could use an else, or I could just use another if statement. If I percent or mod 2, so does not equal to is you put an exclamation point with an equal sign after, is not equal to 0. Graph dot set color dot blue. So if 2 goes, if it's an even number, make the color green. If it's an odd number, make the color blue, and then graph the line. Now we should have a 2-colored wheel, and we do. So this is great, except it won't, doesn't look like it's moving. So the way to make it move is to make the blue lines, oh, let's put a sleep in here as well. Let's go sleep 50 maybe. So that's panel 50 milliseconds. And again, we're only going to see the colors change once around the thing. Boom, quick. Okay. So it's keeping it's going around and around and around. It's actually going to the right, I think, because down is the positive y value. So when we add this sign, this is moving us down the circle initially, so clockwise as opposed to counterclockwise. Because the down is the positive direction of the y value. Okay, so the way to trick this, I think actually if we want, we could just use an else statement here instead of this. Because if it's not even, then it has to be odd. So we could just say else, graph that, and we'll try it like this as well. Also works. Good. So back on paper, I'm gonna show you a trick. The next time around when J is 2, and I is 1, we want this to be blue. And then 2, 3, 4, and then we want that one to be green and this one to be blue again. So what we're actually going to look at is we're going to look at not just I, but we're going to look at I and J together. So if I plus J is even, it'll be green. If I plus J is odd, it'll be blue. And then this one, the first one that was green, when you go to J being 2, 2 plus 1 is 3. Now it's odd, so then it'll be blue. It's sort of a trick. If you have, if you dealt with matrices at all, you know, you have a row and a column, 1, 1, and then 1, 2, and then 1, 3, and then the next row down is 2 with column 1, 2, 2, and 2, 3. And you can kind of look at these kind of have the same pattern. If you add those numbers, you get even, and then odd, then even, odd, even, odd. So that's, I'm drawing on that knowledge to come up with this idea. But now that you see it, now you can draw on the same knowledge. Okay. This is a great little thing to put on a test. I don't know that I would, but like, it's like, did you watch the video? So instead of saying I percent 2 is 0, we're going to say I plus J. And then I think I need to put that I plus J in parentheses. If I plus J mod 2 is 0, put the color to green. Otherwise, put the color to blue. And we should get our spinning wheel. Yay. And I'll go back to our, I mean, you know, not bad, right? Kind of fun. Yeah, it kind of looks like that. I like this one. Anyways, how, you know, so J, it'll keep running. This one runs around the circle 40 times. You could make J whatever you want. You could put text down here. Oh, I didn't do any text, but that's in the PowerPoint. We could put some text, go Seahawks. The text could get bigger. That would be an animation. Moving text around is an animation. So here, the animation that I'm showing you really is the graphing of the using a circular motion. So what would move in a circle if you wanted something to go across an arc? Sometimes it's cool to put the center of the circle somewhere else, or the oval, and then only see part of the arc of the movement. So, you know, hills, I think someone once did a ski jump. The little you know, stick figure is sort of a circle, 1, 2, 3, 4 lines in a circle, and you can draw that and then move the whole thing. Yeah, so I mean, in our animations project, it's 4 components, and you know what you don't want is you don't want 4 of the same thing. But what I'm looking for is sort of something that's nice and that has a clearly defined set of animations. So to me, this one might be, I think it's just 1 animation. You maybe somehow could contrive it as 2, just big wheel here, depending on how you describe it. But like, the bouncing ball might be considered as 2 because it's down and up and you're changing the height. So that height is a different motion than just the bounce, right? So you have a bounce and you have a change in height. So that's 2 components. Any kind of, you know, you know, if it's just something moving one direction, that's like 1. But if then you move it down, that's not really another one because it's sort of the same idea. So you want to try to have, you know, 4 different components within the same scene. I've had some students submit, you know, 4 different things, completely different things, and it's sort of like, okay, yes, you can do 4 animations, but I kind of want them in a scene, in an animated scene. So you're welcome to ask me questions on it, and I have a couple more things that I'll do that again lead into chapter 4. So here we're using the control structure of the if and the else. I just kind of introduced it, and I'll do a little more of that with the color stuff. One thing you could do is you could pull this else back up to there if you want. That's a common way of sort of having them linked. I think I like it there better because it's easier to see. It doesn't matter. You know, maybe I put a comment in here what I'm doing with the colors. We want, let's see, alternate. I'm not going to try to explain it. We'll leave it like that.